I request you to tell your friends who are attempting to join the Google Classroom to join through their NITJ accounts. In that case, they will not have to make any requests and we will not be interrupted while we are having the lecture. So we were over here, we were discussing the framework of mechatronic devices. And in this framework, we saw that there was this portion which was can you see the screen?
No, sir.
I think I've not started the presentation this one. Are you able to see the screen?
Yes, sir.
Yes, sir.
We are going to start now. So in our previous presentation, you may recall that we had we were discussing about the framework of mechatronics devices. And in this framework, we have the mechatronic device itself, which we discussed, could be in any of the physical domains, mechanical, electrical, electronic, thermal, fluid, chemical, any such energy domain. And we have this domain is the analog domain. Now, in contrast, you have the other domain, which is the digital domain, which is actually doing the controlling. So this domain, which you have here, this is the digital domain. And this is where your the entire concept, the software, the inputs from the sensors, the control computations and your outputs to the actuators, the commands, they are issued from here. Now, this entire thing is in the digital domain. It's a digital computer. And you have to understand each part of this framework. In the later part of our lectures on mechatronics, we will discuss the devices, the physical aspects of some of these important devices. We will also learn how to model these devices using the graphical approach of bond graph, how to derive system equations, how to simulate these, how to even go for control using this. And here, now we will proceed towards understanding the digital domain. So the objective now for us is to understand the digital domain. So we are going to understand this domain now. Now, what is this digital domain? When we say the digital domain, it's an abstract domain. So here you're just dealing with numbers or digits. Now, if you see the digital domain, it's because it is abstract. It's numbers. You are dealing with digits. So here you have numbers, and these numbers are represented using digits. So here we are now talking of the digital domain. Now, these digits, how are they represented? How do we represent these numbers? We use digits certainly, but if you see, we take many things for granted. Human beings are comfortable with um, the decimal system. Even when you were small, you learned the decimal system, you learned how to do all the operations using the decimal system. Now, the decimal system has a base. This is just a review which all of you know, but I suppose it is necessary for us to review this because over the years, my experience has been that we take this aspect to be, we take this for granted, but many students have gray areas in these concepts. So take this opportunity just to review your fundamentals, things which you have already done. So here in the decimal system, we have the base for this number system, and the base is 10. And if you if you try to represent this system, let us say that you um, represent it using digits like this. So I'll represent it using squares. We'll add more squares now. So let's say that we have another square here, and we have yet another square here. Now these are all digits, but these digits are in the decimal system, and you can see that this digit it is in the base 10. So here you have various values possible for this. You can have in this bit you can have 10 possible values, and we know those 10 possible values are 0 to 9. So from 0 to 9 we have 10 possible values. Now each of these digits it has a weightage. So the digit over here, it is the least significant. So here 10 raised to 0, that is 1. And we have the weightage here as 10 raised to 1. This is corresponding to 10. And here we have 10 raised to 2. That is 100. You can go on adding more boxes. So you'll get 10 raised to 3, 10 raised to 4, and so on, depending upon what you want to do. Now, suppose you want to represent this, you want to represent a decimal number, let's say 123. Okay. So this number 123 is in the decimal domain. It is in the decimal system. So we can write this as this number as 3 into 10 raised to 0. That will be equal to 3 itself, plus we'll take 2 which is over here, and this multiplied by 10 raised to 1, which is its weight here, corresponding to this digit, and that is 20. And we have the third one here, that is 1 into its weightage, which is 10 raised to 2. So this is a 10 raised to 2. That is 100. When you add up, you get 123. Now this addition you did in the decimal domain. But this is very comfortable for human beings, and possibly it is because we have 10 fingers and we can do our arithmetic with our 10 fingers, adding, subtracting, etc. So it's convenient for us. But this is not how the arithmetic is done by machines. For machines, we require something more simpler, and that simpler is achieved in this manner. Let us say for machines, we have not the decimal system, but we have a system which is based on a different base. It's called the binary system. And perhaps there is wisdom in this choice. It's easy to implement. It's easy to implement for machines. But the base here is 2. So if you take a binary uh, digit, and if you will take it here, it can have only 2 possible values because the base is 2. So let's say uh, this is a binary digit, and this binary digit is actually called a bit, BIT. Unlike the decimal digit which we had here, which could take 10 values. So here we have values, it can take only 2 values. And those values are 0 and 1. So suppose you want to represent something, let's represent something in binary. So in that case, make use of this itself. So here we have the boxes corresponding, the digits corresponding to the binary system, and here the base is also different. So here we have 2 raised to 0. Here we have 2 raised to 1. So 2 raised to 0 is 1 itself. 2 raised to 1 is 2. 2 raised to 2 is 4. Okay. So the weightages just go on doubling up as we go towards the left. So as more and more weightage is added, if you the weightage just doubles. In the decimal system, the weightage was just being multiplied by 10. So you just had to add zeros on the right. Now suppose you take the number 101 corresponding to binary. How do we represent this number? So we can represent it as 1 into 10 raised to 0. That's corresponding to the weightage of this. That is equal to 1 plus we have 0 here. So 0 into its weightage, it is 2 raised to 1. Sorry, uh, I suppose you all are not paying attention. Otherwise, you would have
So
corrected
it
this.
would be 2 raised to 0.
Thank you very much. Somebody is paying attention at least. Good. So this will be 2 raised to 0. This will be 2 raised, and this will be 0 into 2, that is 0, and plus 1 into 2 raised to 2. So this is equal to 1 into 4, that is 4. And when you perform the addition, you get 5 here. Now these additions which we did, they were in the decimal domain. So I'm going to put a small suffix here, 10. Here also small suffix here. This addition is in. But this representation which we had here, this was in the decimal domain. This representation 101, it is in the binary domain. So 5 is actually equal to 101 in the binary domain. 102 base
सर ये
10.
सफिक्स 10 के रिप्रेजेंट कर रहा है
It is representing the system. It is the
सर फिर
decimal
तो
system. This is the binary system. Okay.
ओके
Just to distinguish, that's all. Okay. Uh, now let us proceed to the next aspect. Suppose we have to represent these numbers. We want to represent larger numbers. So we have a definite system how this is to be done. And the system is something like this. Uh, let us represent numbers in various number domains. So various systems. Let's say we start with binary. Here we know the base is 2. Okay. We'll also have the decimal system. Here we know the base is 10, and we'll also have the hexadecimal system. Here the base is 16. Okay, and let's see how we represent these. Just to draw lines. Just to separate. And we just multiply these. Perhaps we may need more. Just keep them handy. So now let us begin representing some numbers. Let's say we start with 4 bits: 0, 0, 0, 0. This is in the binary system. Okay? And decimal representation of this is 0. Hexadecimal is also 0. Next, we'll increment by 1. So we'll get 0, 0, 0, 1. In the decimal system, it will represent 1. And in the hexadecimal also, it will be 1. Then we go to 0, 0, 1, 0. Here, decimal representation is 2. This is also 2. Then 0, 0, 1, 1. You see, we are just increasing by 1. So here it is 3. Here also it is 0, 0, sorry, this will be 0, 1, 0, this is 4, this is also 4, then 0, 1, 0, 1, this is 5, this is also 5. Then we have 0, 1, 1, 0. This is 6. This is also 6. Here you have 0, 1, 1, 1. This is 7. And here also you get 7. Then 1, 0, 0, 0. This is 8. This is also 8. Here you have 1, 0, 0, 1, 9. Here also 9. Then 1, 0, 1, 0. This is 10 in the decimal system. And you can see that now you are representing this number by 2 digits. This is written as A. In the hexadecimal system, we just use 1 digit only for this. Here, 1, 0, 1, 1. This is 11. Now you are representing 2 digits using 2. Here it is B. 1, 1, 0, 0. This is 12. This is 6. Then 1, 1, 0, 1. This is 13. And 1, 1, 1, 0. This is 14. And finally 1, 1, 1, 1. This is 15. This is. So you can see that you have started for representation of 4 bits. And these 4 bits, when we arrange numbers in a form like this, okay, we call them as, this collection is called as a nibble. This collection of 4 bits, this manner, it's called a nibble. So here, for a nibble, you have 4 bits. Now you can see that you started with all zeros, 0, 0, 0, 0, and you went on incrementing and you came up to all ones, 1, 1, 1, 1. So the nibble which you are using, nibble of 4 bits, is completely full now. If you want to add anything more, you need to add 1 more bit to the left. So this is your representation in the binary domain. And this is the representation, corresponding representation in the decimal domain. And this is the corresponding representation in the hexadecimal domain. When you are representing decimal numbers, say we were talking of the number 123. So if you say 123, and this is in the decimal domain, let's say, decimal system. How are you going to write this in the binary system. So for that, we will require weightages. So here, let's say we take one box, take another box, keep on taking boxes like this of different weightages. Let's say we take a box of 64 weightage, 2 raised to 6, then 32, 2 raised to 5, 16, 8, 4, 2, and 1. So we have taken various bits over here, and we are now going to perform the addition. So here, if you take 1, you're having 64. If you place here a 1, you will have 64 plus 32, that is 96. So you place a 1 here. 96 plus, if you do 16, you will get 102, 112. Okay, 112. 112 and 8 will be 120. But you want 123, so you can't add a 4. You can then add a 2, and you can add a 1. Now, this is one way of representing 123 in the binary domain, in the binary number system. So, this was the decimal, and this is binary. But there is another way of arriving at this, and I'm sure all of you must have done this at school itself. You have the number 123, you go on dividing it by 2. So you divide it by 2. Okay. So as you go on dividing, so here 2, 6 is 12, 2 1s are 2, but you have one remainder. Then you again divide by 2, 2 3s are 6, 2 zeros are. So here you have again one remainder. Then you again divide by 2. Now it's okay. 2 1s are 2, 2 5s are 15. Remainder is 0. And you again divide by 2. 2 7s are 14. You have a remainder. Again you divide by 2. 2 3s are 6. You have a remainder 1. Again divide by 2. 2 1s are 2. Remainder is 1. Then again you divide by 2. 2 zeros are 0. Remainder is 1. So now you have all these remainders over here, and you arrange these remainders in a particular fashion. You arrange this like this. So place this 1 here, and arrange this 1 next to it. Then this 0 next to it. And these 4 ones. So you have this representation in one nibble, and you need another nibble, but a little less than a nibble. So you have this as the decimal represents the same over here. You have this uh, representation, the binary representation of the number 123. Now, how are you going to represent this in the hexadecimal system? It's very simple. You take nibbles. So here you have the nibble on the right is a lesser significant nibble, and the nibble on the left is a more significant one. Now this corresponds to 1011, and you can see a 1011 is B. So this corresponds to B, and this is 0111. 0111 is 7. So this is 7. So 123 represented in the hexadecimal system is 7B. So we can write 123. This is in the decimal system. We can write it as 1111 This is in the binary system, and we can write this as 7B in the hexadecimal system. Number is the same, but the representation in different energy domains is different. Okay, so now we will come to the operations that we can do in this. Save this slide. Now, in the operations that can be performed, we can do various arithmetic operations. You are already familiar with. Now let's start with say addition. So we'll take simpler examples. This just to supplement your understanding. So let's take addition of two numbers, say 5, decimal 5, and 9, decimal 9. And let's add them. So we know the answer should be 14 in the decimal domain. This is our expected answer. And if we are to do this in the binary domain, so we are going to write this as 0, 1, 0, 1. If we use a nibble, and 9 we can write as 1, 0, 0, 1. And we add this up, 1 plus 1 is 1, 0. 1, 0. 0 plus 0 is 0, but we have a 1 carry, so that is over here. 1 and 0 is 1. 0 plus 1. So we have 14. So this is actually in the binary system. 14. If we have to do multiplication, you saw here that the carry is just like what we do in the decimal system. 1 plus 1 is 1, 0. So 0 we carry over 1. Okay, and then comes here. Now suppose you are interested in multiplication. So for multiplication, let's take these two numbers itself, 5 multiplied by 9, and we know the answer as 45. Is known to us. Now if we represent 5 in the binary domain, it is 0, 1, 0, 1. 9 is 1, 0, 0, 1, and we perform this multiplication. So you get 1 into 1 is 1, 1 into 0 is 0, 1 into 1 is 1, 1 into 0 is 0. So you see, whenever you multiply by 1, you are just reproducing this upper pattern over here. We go to the next digit. So here 0 into 1, 0 into 0, 0 into 1. So all these are zeros. So 0, 0, 0, all these. And the next digit. So here 0, 0, 0, 0 again. 0, 0, 0, 0. And finally, the last one. So you reproduce this as it is 1, 0, 1. And this becomes 1, 0, 1, 1, 0, 1. So you can represent this. If you add one more 0 here, you will have 2 nibbles. So, and you can see that you have got the answer as 45. If you perform the weightages, you can see 1, 2, 4, 8, 16, 32. Okay, so 32 plus 8 is 40, 40 plus 4, 44, 44 plus 1 is 45. So you can see this is the representation for 45. So you did not have to remember any tables. You did not have to mug any tables. You remember the time when you were young and you had to mug up those tables, memorize those tables. And if you would have followed the binary system, you would have avoided all this drudgery. Okay. I think we will proceed with the division and subtraction in our next lecture. So we have yet to review the operations of division. We'll do that in our next lecture since we are approaching our finishing time. So I'll just wind up the lecture here itself. So if you have any questions, you can ask me. Please don't hesitate to ask questions in the next lecture also. In the next lecture also, you can ask me. If you wish to interrupt me, you can certainly interrupt. You can make it brief and then tell me whatever. Maybe I must have made a mistake or must have missed something. You can point it out. Okay. So with this, we will wind up the lecture for today. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.